Hello everybody, Всем привет. Today we're gonna talk about a breakthrough that I had in reverse engineering the map format. Um, so what, where I've gotten so far is I'm able to display the creature structures in the castle. I have this one maxed out, but in my code I'm just setting it to like max value. So I'm storing basically just the castle structures in some sort of memory structure, and I set them all to 1 instead of 0 just to see what this looks like. And I really wanted to test the rendering. In my last video I went through the rendering order, and so this is great. I have the castle rendering. There's still a lot to be done here. I even got the big bar on the bottom, so I've successfully rebuilt this screen. What I need to figure out now, this whole like map of the game, I've had to reverse engineer this from the map file. And the map file, actually all the maps in Heroes 1 are 72 by 72, 32 by 32 pixel tiles. And then you have this border around it, which is a whole thing. And then this mini map up here. So I figured out how to do all of this from the existing game files. And I figured out the sound map. I figured out a lot of things, but one thing that is missing is what is the start state of these castles. So this map is Claw, the famously easy Claw map, and you start with two basic creature structures, a thieves guild, tavern, and a well. And that's pretty consistent. And so I was like, well, again, 2 creature structures, thieves guild, well, or thieves guild, tavern, and well. Now, if we go to like some other maps, let's go to Badlands, for example. So here we start with 2 creature structures. That's it. Okay. Let's just reload that and see if it's the same. 1 creature structure. So there's a certain amount of random generation on some castles. That's interesting. And Vertigo, I think that was the name of a town in one of the original Might and Magics. So let's just look at yet another map, Crossroads. And this one, I believe, because you always start in the middle of this map. You have, various characters on either side of you. You always start in the middle of this map, and you always start with a single creature dwelling. So a number of maps, and if I actually pull up the map names, pull up the map names here, we can so in the map names, this is Claw, this is I forget which one this is. We have maybe that's Archipelago. Dragon Rider. You know what? I actually have a listing where I can tell map names. Let's go to map format. And we bring this up. Here we go. All the way at the bottom. So we have So Badlands here. These are basically the file names of all the original DOS maps. These are the file names of the Windows 95 maps, and this is my favorite community map, Dragon Rider, which actually was created by this guy Jason Church after they created the map editor, and he won the contest, and then his level was actually like made in Heroes 2, so it's one of the default levels in Heroes 2, but the original is on Heroes of Might and Magic 1, created by this Jason Church guy. And anyway, so you'll notice the DOS maps here are 60 kilobytes. The Windows 95 ones are about 80, and I'll explain why that is in a little bit. The assignments of which castle you end up in are actually encoded in the file names somewhat. Like 0234 is a multiplayer map. So there's two of these. This Four Corners is a multiplayer map, and Archipelago is a 4-player map. Let's see. This was Badlands, right? No, this is Crossroads. Yep, that's what I was looking at. So Crossroads here is a 100. So that means you're going to start at the same fixed castle each time. Same with Claw. You always start at the bottom. This Knight's Quest, you're also going to start somewhere, specifically the Jester. You start in the middle, kind of similar to Crossroads here. And two if by C and Jolly Roger are ones where I believe you can end up in one of two castles. It will randomly assign you one. Let's just have a quick look. 2 if by C. How about that? So looking at the map here, we have one of these two castles that you can end up at, and then these other castles that you have to go and attack, I guess. So basically you're going to be assigned one of these two castles, and it may only be 2-player, but and it may actually also just be that the second player, if we played Hot Seat, we could actually try this. We can do let's see, new game, multiplayer, Hot Seat, 2 players, and let's try it 2 if by C. Yep. Okay. Yep. And yellow is over here, so that's the second player. And let's see, we do standard, multiplayer, Hot Seat, 2 players, and you'll notice that Claw is not available here. So the 100, those are single player maps. Crossroads also not available here. The Jester is probably not available. And what about Knight's Quest? Yep, Knight's Quest also missing. So basically those are true single player maps. Now you can hack this, and you can just change the file names here. So if I make this Claw 1234, it can be a 4-player map. It's a bit unfair because the first player starts out with a bunch more stuff, which we're about to see. So yeah, let me get into that. So I have previously pulled up some different maps. One thing that I was looking at, let me see if I can find Claw Tail here. So this is let's see, let's turn off word wrap. This, you can kind of see the Claw map format here. This is the collision grid. I wanted to look at tile 7 out of 10. That was one thing that I dumped. I also wanted to look at the sound effects overlay, which also looks like this. And then I was, and the reason for that is I'm about to start working on some collision stuff because if you'll notice in my current build, down here, I can't actually like pick things up yet. I can walk through stuff, but I'm not able to, you know, that this is one of the next major things that I have to fix. And it's not going to be that hard, but I just need to sit down and do it. So I'm working on that, and I'm also working on the sound map because I want to start playing the sound effects. Anyway, further on in the game format, like you have these 10 bytes of 10 bytes per tile, and there's 72 by 72 tiles. So that's about 51,000. Well, it's actually 51840 bytes. So 51,840 bytes. That's the bulk of this 60 kilobyte file. The bulk of that is that map. There's also another 5,000 in a sound byte map. That's yet its own 5,184 byte tile map. So the bulk of this game file is those two maps. You know, and it is a map file, that makes sense. But there's also a few other things. You know, at the beginning of the map files, you'll see some. There's a fixed header, which I'll show you in a second. I guess I can actually just pull it up in the hex editor here. So the file starts out, this fixed header gives you the title name, and then it has spaces for German, French, Spanish, Italian, and even some additional other languages. It has just this padding for that. And then it gives you the map width and height, and then it very quickly starts into the tile blocks. After the tile blocks, there is a list of the castles, which gives the coordinates. There's a list of the mines and two special structures, which are the lighthouse and the dragon city. And after that, there's this section 3, which is this sound effect tile overlay, which I've dumped here. And this, you know, this is things like 1010 is a sawmill sound, for example. This 0B is the windmill sound. And after that, you get into these object record headers and castle records and castle and hero records, things like this. So this was an area I didn't fully understand. And in Windows 95, the Windows 95 maps, there is an additional 4-byte tile region. So that is 4 times 5,184, which I think is 20,736. And in Windows 95 maps, there's this extra, you know, almost 20 kilobytes of size, which covers those 4 tiles. And I still don't know what those 4 tiles do. I can basically recreate the game without knowing what those 4 tiles are. My theory is they're related to the map editor. They let the map editor load faster. It could also be some Windows 95 loading optimization. That's what I figured out so far. Anyway, the breakthrough that I had was realizing, well, I'm still, you know, going back to first principle. What are we trying to do here? We're trying to figure out the build structure of this castle. What, you know, this is me just specifying in memory what is there, and that is not like the map has this encoded somewhere. This is the same every single time. It's not randomly generated, at least on this map. And so where is this information encoded? And so I started looking. I created a file, or I created a script to dump these various pieces of the game as we, as I understand it. This is one of the tile maps. So I'm able to view some of the sections of the game and remind myself from my notes, what the different sounds are. Okay, well then I also print out a list of castles and the locations and who, what type of castle it is. So I've written some scripts in Python to decode what things are. And we, this map, Claw, doesn't have a lighthouse or a dragon city. It does have, it looks like 19, it has like 17 mines, I guess. And actually, no, that would be 20, 18 mines. It has 18 mines, zero-based indexing. I also highlighted the town entrance tiles and had a look around these tile entrance tiles. I thought that maybe the B9 on the town entrance tile was some binary, this would be like a binary representation of what is built in the town. That was not the case. I was looking at these and it kind of seemed to be more sequential, like 7, 9, 11, 12, and I guess 0E comes after 09. So this is like 7, 9, something else, and then these are in hex, these come after that. So so there's some sort of sequence here, and I was like, well, they're kind of ranked. And what I then did is I just asked the game to dump the tail bytes. Everything after this address is like the end of the sound map up here. So the section 1 here is the castle list, section 2 is the mines list, section 3 is this sound map. And then after this value, after this last FF here, there's a bunch of stuff at the end that I don't know what that is. What is that? And I had been able to get to this point of, figuring out the map without knowing what that was. But now it's time to dig in and figure out what it is. So my first thought was, okay, maybe the castle information is hidden somewhere in these tail bytes at the end, because it's not here. It's not in these B9 bytes. And just zipping back here to our map format, I'll quickly review the tile structure, which I think is up here. Here we are, tile record. So our 10-byte tile record, we have bytes 0 through 9. The first layer is the ground tile. This layer 1 ICN, tells you sort of which ICN image set the file image is going to be, and then this is the index frame of that tile. And we have some other stuff, whether if you have a resource cart, other things. Collision means this is passable or not. I think I need to work a little bit on this because there's some stuff with the collisions, but I'll get to that pretty soon in a coming soon video. But what we're really looking for here is tile type and the auxiliary data for tile type. So in my tile type, I've marked out things that are non-entrance but non-passable. So these would be like decorative things like the outside of the nomad tent body, or the outside of the oasis, or the outside of a minecart. Like these are marked as non-entrance but structural tiles. That's what I called them. But then you have actual entrance tiles, and you have things like the town entrance or player castle entrance. Sometimes these are labeled C0, C1, and then A8. And here in my map format, I thought this was build state, and I actually know now that it's not. So I'm going to actually just remove this. I'll update that in a second. When I just forgot to update that in the documentation. But anyway, my first thought was that this byte 9 here, which is auxiliary data, yes, well, this did get updated. This did not. So we'll update that later. But byte 9 is this auxiliary data. So when we have a monster, it's the creature count, and all the other possibilities for this are for, well, there's also a pre-placed hero, and then there's the actual castle tiles, which are A8, C0, C1. And my first thought was, again, that this B9 was giving us this build state, because these heroes are always randomly generated on maps like Claw and a lot of these DOS maps. And so what are we going to do? This isn't the value. This isn't consistent. This is some kind of sequential series. You know what? Okay, well, so I wrote this script like the next step of reverse engineering is, okay, let's roll up our sleeves and let's look at the tail bytes. Let's look at everything else that we don't know what it is, and start looking for encoding information. And so I start looking at this. I noticed this 13 at the end. So this very first value is 13. Well, that's interesting. So my next theory was that this value, which appears in every single game file, I was like, what is this 13 here? And I cross-checked it across a whole bunch of files. I got out a little notebook and I wrote that down for each map, and nothing. That is also not the answer. It's not sequential. It's kind of a random number. So that wasn't helpful. We have some zeros here, and then we have a 46, which is this, I guess, an ASCII F character. And then you go on a little bit further down, we have another 46, and if I highlight these in my code editor here, and I can actually blow this text up a little bit, so maybe it's a little more visible. The code editor here, there's a lot of 46s. Huh. Look at that. There's a lot of 46s. Then, okay, we do actually have some values in here. There's something in here. What are these values? Okay, 9003, 0102, 80, like, okay, but there's still consistently, there's a lot of 46s, which are this ASCII character F. The dot, I think, in the hex editor is for non-ASCII characters. And then we get down to the end here, and then there's, it just sort of unceremoniously stops with zeros. But we do have this last 46. So I basically said, hey, this 46 does look like a termination. Why don't I take the 46 and let's take everything that ends at 46 and just see what that looks like. And so this was kind of my process here. Now I basically built the script that generated this by dumping in some of my data into the AI and highlighting, okay, we don't know fully what this gray area is here, but it's always FF. Then we have this section 3, and the AI kind of makes a mistake here. And doesn't recognize that there's actually more to the file. But I wrote a map dumper, and I said, let me dump these, like all bytes after E517, which is the end of the sound map. Let's dump all of those, and then let's dump tiles on bytes where the byte, where the castle is this value. I want to look at the flag bytes. I want to look at the minecart bytes. I think I already know that byte 9 isn't the build state, but let's check it anyway. And so I was trying to be thorough and just have another look at that in case that somehow the build information was like in some of these bytes that I don't fully understand. Like I have a pretty good idea of what they are, but like maybe they somehow compress the information into those bytes. Well, okay, it did this for me. It gave me some minor bugs, and it was basically just that my Windows terminal can't print certain characters. So it fixed that for me. And I came up with a version. You know, this was my outputs of the different tiles, and I didn't see anything here. Basically, that's the outcome. So that idea didn't work. So I was like, well, let's try something else. Let me cook up another script where we're starting again at this address E518, and right now I have this theory that the byte has some there is some info about the castle build state in this last byte, and that is again going back here to this. So I'm testing this theory of this byte, and so I took the maps that had that I just took the first few maps, and I said, okay, well, this one is 17 in hex. Claw, which we're looking at here, is 13. Dragon Pass, 15. Badlands, 16. Close Quarters, I guess I mistyped it. It's 11. Crossroads was 0D in hex. So I was like, let's look at those. And then I also want to dump the end of file data for each map, and also the tail byte and the castle entrance bytes like we did before. And so, and then I want to do it. I want to process all the maps in the map directory. Let's just look at everything, do it all at once, batch process. Gives me some suggestions. I come up with this, you know, dumping the values of what comes out of each one. And what else did I ask it here? I said, you know, maybe that is some kind of file length checksum for E518. So it comes up with some math here and says it's this tail value -4, 74 plus 1. Verify the one outlier. There's one outlier of this map Knight's Quest, and it's explained by the mixed record size case already documented in your map format MD, which was me previously looking at this and kind of trying to analyze it, and the game points out, oh, well, sometimes it's 74 bytes, sometimes it's 79 bytes, and because those are mismatched, it's not exactly right. So this is not a build state byte at all. It's the hero record count field, byte 0 of the 5-byte Windows 95 record header. Now, I knew this from a previous a previous version of this where, let's see, do I have the hero decode file? Where is that? All right, well, I'll find that in a second. But basically, I had previously decoded the Dragon Rider map and found where the hero was generated. And I determined that the hero was placed at C7, and then the auxiliary byte 9 was the index in this hero record count later on in the file. So basically this area did contain hero records in Windows 95 maps, but that wasn't the case here in the DOS maps. The DOS maps, you couldn't specify the heroes. That was something that was added in the Windows 95 maps. So so the AI had kind of, and it did this a couple times as I've been reverse engineering it, it makes mistakes about what's Windows 95 format, what's DOS format. It's all context to it. And it's not keeping them clear every time. That's not delineating between these as much as you would hope. But basically it says we still don't know what this castle build state is. And so I just keep trying it a different way. Like, let's you know, let's try something else. Let's look at the maps that have this 1, 2, 3, 4 or 0, 2, 3, 4. They have a random starting structure of a castle and one creature dwelling and about a 10 to 20% chance of a second creature dwelling. And then these other maps have fixed values for the castle. Maybe something is encoded in the map name. You know, I'm really stretching here. I'm like, where is this info? Like, it is here somewhere. So then I decide I'm going to dump 2 tiles before, 2 tiles after, 2 rows above. Like, let's just look at this 5x5 grid around the entrance, and let's see what we're dealing with. So I run this. I didn't think it was transposing things correctly. You know, this was some of the outputs, for example. And actually, I think it was the way it was listing coordinates was transposed, but it was actually processing them correctly. So it was like listing the coordinates in YX format, which technically means they're not transposed, but it's just a little unintuitive for most people who've had basic algebra do things XY. You know, Cartesian coordinates from Descartes are XY. So the AI was doing it backwards for some reason, and well, it didn't matter because as I followed up on this theory, that didn't work either. So, all right, so B9, the auxiliary is a sequential slot index, not a build state encoding. So this was, you know, I had noticed that these values were sequential. Where did I have those values? Yep, here, the B9. That these values in this column here, B9, were approximately sequential. And it starts to look at some of these and determine that, yeah, you know, these are probably some kind of reference. And maybe it points to hero records in the tail, because we've seen hero records in the Windows 95 maps. Like, I know that those exist there. And so I was like, okay, well, why don't we, again, I mean, the AI is suggesting, let's look at those 74-byte hero records and see what's in them. And so I started playing around with some of these values, like this value 09 here, and I'm going to pull that up in the hex editor here. So I started playing around with some of these values, and like, I'm just going to show you guys what happened. So let's make this a 1. And this is in my Heroes of Might and Magic game file. What happens if I reload Claw now? If I just make a slight change to that, what is going on here? I can't move. I don't have a castle. And my castle belongs to the yellow player now. Cool. All right, yellow player got it. So that actually implies that this specifies who owns what player. Huh. Interesting. Which castle owns which? Or which color, which hero owns which castle? So and this was just in one of these 46, you know, terminated records. So I was like, okay, I want to look more at these records. So I realized, okay, so definitely some kind of hero spawn index. No, it's not definitely. Come on, AI. You're a little too sure of yourself, Mr. AI, Mr. Claude. That means the build state is almost certainly inside the 74-byte hero record itself. Let's write a focus decoder for the tail hero records on the fixed maps. Okay, so it goes through, dumps all this, and here I'm figuring out the exact bit mapping, but I think it's bytes 4 to 5 of the hero record. The hero record referenced by the aux byte of the castle. In this case, the 9th hero record of Claw is this. So this is referenced by B9 is 009, which is the player castle C1 at 5137. So this is actually, yeah, this is YX again. So that is actually correct notation, but you see how I would think that was transposed. Because it's actually, this is the Y value and this is the X value. So anyway, it highlights, it thinks that we have the player owner in this player 1 slot, this byte 2, which I had found here. You know, we had this 46, we had a little bit of padding. I guess we had 4 bytes of padding, this 00000001, and then this was the value that I changed, that changed it to a different owner. So okay, that's something. So this is actually probably right. This 9601, well, there is no creature ID for 9601, no creature quantities, so it wouldn't show up anyway. There's no artifacts, there's no experience, like, and then it says build state suspected here, and it's all zeros. And I'm like, this doesn't look quite right. These are the raw values that we're seeing here, and that basically corresponds to this space. And anyway, I point out to the AI that the 4th and 5th bytes here, not using zero-based indexing, are 9601. And changing those values changes structures in the castle. Let's read those values for other maps. So help me write a script to dump these hero states of these different maps. Okay, well, I'm just going to show you guys what happens if we change some of these. So let's make this 1-1, and let's make this like A. How about like A or something? Let's just see what that is. Now it was 9601 was the original values, but let's load up Claw. And what is in our castle here? So we have a Phoenix Tower. We no longer have a tavern. We have the first 2 structures, and we have a shipyard. So we lost the well, we lost the tavern, we gained a Phoenix Tower. Well, whatever's going on here, we have found the initial castle state. And what I then did was, I looked at, so yeah, there was a low bit and a high bit here, because these are little endians. So basically, this bit here, I'm going to rename this 9601, just so we remember to change that back. These are little endians. So this is actually the smaller bit to this byte. This is a more significant byte than this one. So that's why this is called the high byte. So I did another dump, and I basically created a table to decode what was in these various files, and I should be able to pull that up here. I think it's this. Yep. So you can see, I don't know if you can see it that well, but I basically did a test of, so I input various hex codes. Here's our 9601, 9001. I thought there might be something to account here, so I put that in, but that turned out to not be useful. And I just did this on a creature dwelling setup here. It doesn't actually matter because the faction isn't specific. It's just generic creature level 1 through level 6. and I determined that basically the second byte, you know, 1F gave me the full creature stack. So if we go in here, we make this 961F. Let's see what that does quick. I mean, I just told you what it does, but seeing is believing. So let's pop in there, and we have a fully built castle, creatures ready to go. Look at that. So that definitely is the creature build state. And you know what? What happens if we drop it down to 0, 0? What happens if we build no creatures? If we nix them all? What happens? We still get the peasant hut. So basically, the peasant hut is the default, like 0, 0 encodes the peasant hut. So I don't know if it's possible in Heroes of Might and Magic 1, in the first one, to have a truly empty castle. I don't know if that's possible. Anyway, the first two, well, the first byte here, these, I guess a nibble is these 4 bits here. So the 9, 6, I'm trying to figure out what that corresponds to. So I mean, I know now that this corresponds to, so 9, 6 corresponds to the Thieves Guild, the Tavern, and the Well. The Well is just 9001, so I know that 9 is the Well, basically. The other one I broke down, I did 0101 and determined that's the Mage Guild, 0201 determined that's the Thieves Guild, 0401 that's the Tavern, and 0801 was nothing. Oh no, actually that's not right. That was the Shipyard. I tried some other things. I basically couldn't get Mage Guilds level 2, 3, and 4. So I don't know how to create a castle with Mage Guilds level 2, 3, and 4. And the thatched hut is a default state. And I have an isCastle variable that I'm detecting from the tile type. So the map is telling me whether it's a random town or a random castle. So it's not triggered in this either. The castle status isn't. Although I think there's a possibility that it is somewhere in this, but it kind of doesn't matter for the purposes of developing further. You know, I can figure it out later if it's important, but it's like I probably don't need that information because it's redundantly encoded elsewhere in the map. So the cool observations, the big breakthrough was figuring out this location, figuring out roughly what these bytes map to each other and decoding it this way, just doing a lot of inputs and outputs. This isn't quite a full digital logic truth table. You know, that's what a computer engineer would do to reverse engineer a processor. They would put in a bunch of ones and zeros on one input and see what the outputs were on the other, on the output. And so when you you do some inputs and you check the outputs, you're basically figuring out what the logic connection is between the inputs and the outputs, and that like structure, the table of that you develop is called a truth table, and it's something in digital logic. They teach it at probably second year engineering school. Sometimes computer scientists learn it, but usually it's electrical engineers, computer engineers that focus on that. So anyway, we're back here. We have some of this working, but we found the initial goal, that we got the breakthrough. But I basically asked the AI, like, hey, help me figure out the bitmap here. What are we dealing with? It doesn't understand that Cathedral is dwelling level 6. Not perfect, not all knowing, but you know, it's something. So this bit 7 is always populated, so it thinks this is what I think might be the castle bit. And and it's asking, hey, does this mean it's a knight faction? No, it does not, AI. It's it's just it doesn't matter what the faction is. So I think B0 bit 7 might be the castle designation of the low byte. The creature factions were just an example. The behavior of the structures is consistent across random castles, not just the knight. Bits 5 to 7 of B1 are not related to the Mage Guild. I set it to F and nothing changed. Same with bits F6 of B0. So it was suggesting, by the way, that maybe the Mage Guild, maybe the additional Mage Guild levels were these, or actually no, it was suggesting maybe it was, let's see, yeah, of B1. So it was suggesting that these might encode the Mage Guild. And I was like, nope, that's a nice thought, but no, it is not true. So this was the confirmed map that it came up with. And I'm like, but it's also like, oh, I'm not sure because you didn't test the armory and the jousting arena independently. And I just said, don't worry about it. They're basically, I'm sure. And then we start looking again at this. I looked at some other maps, Windows 95 map, Empires at War. I see some offset of 3 bytes that's leaked into the hero records. So here, the 46 of the last byte is leaking in. And then we're getting this 0001. And then we get a 03, so that's like probably player 3 that owns it. And then we get our build state of the castle, which is 8503. And I found this map, this Empires at War. I found this map because I was looking for other maps where the hero spawned with a bunch of extra stuff. And I mean, I could talk about it. Why don't I just show you? So I was looking for maps where you have additional heroes, additional castles, and the castle was a non-standard generation of, like, most castles either have nothing, they have the just the first creature structure, or they have the first and maybe a randomly generated second creature structure. That's like what 90% of these maps are. There's just a few that actually start with other things. So this was like a mage guild and a tavern. Let's see, that was this one. This one here, also Mage Guild Tavern, but this has a third creature structure. This has the griffins. And then this is just a tent. And this one, also just a tent. So this is like the minimal castle, whatever. We also have a couple of these guys with some centaurs. But what's also interesting is we have a garrison starting here. So when have you seen a garrison in a non-Windows 95 map? I don't know if you have. Maybe in the campaign games, which I have not started. I have not decoded the campaign maps yet, but this is also interesting. So we've got this, but we have some garrisons. This one is 40 and 20, and this one is 10, 20, 40. So let me go back and look at this. So this was Empires at War, and I see this 8503 and then a 0, and then I start to see 678, which to me looks like, these look like monster ID codes. So let me pull something up here. We have game data. Yep. So, oh no, game data doesn't have, oh, here it is. Yep. So the creature ID codes. So that was, we were looking at this. This was 678, right? So someone is starting with 678. They are starting with goblins, orcs. Oh, this isn't correct. The AI has generated this from Heroes of Might and Magic 2 context somewhere. It got, that is, oh man. That's brutal. The AI has inserted Heroes of Might and Magic 2 information. I gave it correct information and it re-summarized it. Oh boy. Not happy about that. Peasants, archers. What do we have next? It's pikemen, swordsmen, cavaliers, I think, and paladins. Oh my god, this was really bad. Sprites, dwarves, elves, druids. Wow, didn't even have Phoenix. Man, that is not cool. One of the dangers of vibe coding is this happens to you. Okay, it got the warlock correct, and somehow I like to feel like I have a good grasp of what's going on, and sometimes it just you 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4 5 6. I mean, I know these by heart, but yeah, I think the AI has a lot of context from Heroes of Might and Magic 2 and Heroes of Might and Magic 3, which are more popular games. And so sometimes it will just fill in, creature lists, and using its context, it's more statistically likely to generate a list from Heroes of Might and Magic 2 or 3 than it is to generate something from Heroes of Might and Magic 1. Now, the fact that I'm using this AI and I'm not protecting it necessarily, a lot of this information is going to probably be used to train Claude. So maybe Claude is going to become more biased towards Heroes of Might and Magic 1. I'm sorry to anybody who's using AI and develops on Heroes 2 and Heroes 3 or other Heroes games. I'm expanding the data set, but it may make it less likely that it's correct for you, and it may do something like this, but using Heroes 1 data instead of others. But anyway, so I was pointing out that we found a hero record here, or a castle record that has 6, 7, 8, and then there's a space of these, and then it starts to have some quantities. Well, what is 32 in hex? 30, so this is 3 times 16, which is 48, plus 2, which is 50. And then 0, and then a 1E, which is 16, plus E, which I think is 14, so that's going to be 30. And then 0F is 15. So this is 50, 30, and 15 wolves. And then this 0, 0, again, this is going to be a little endian thing. So this is the smaller byte, and this is the larger byte, smaller byte, larger byte. So you can have up to 65,535, I guess, of each creature, technically, by this. And then we have a bunch of zeros after that. So, but I'm basically pointing out that my script here is treating this like a hero that I had decoded from finding Castor, the hero with the guy with 1 dragon, knowing his portrait number, knowing he has an artifact. I was able to look up those IDs and figure out kind of the, and where the experience was. I reverse engineered this, I think, in a previous video. And so now I'm like stumbling upon something that looks similar but isn't. And so this is probably the castle data. This is probably the garrison data, probably for whoever the barbarian player is in that level. And so I'm kind of pointing this to the AI and saying, hey, this is a little off. There's this 0046 where we're not, something is off with our math that's computing this. And I just had it look at this, and it's suggesting that the DOS and the Windows 95 formats have different record prefixes. Maybe. There's also these 4 Bs that appear in the Windows 95 files. So it's just 46 in the DOS, but in the Windows 95, it includes both of these values. And it turns out that this value that we had found at, like this value is a record count. So this counts how many of these records there are. So we have some kind of records table, but we're still not fully decoding these. So I'm suggesting that it update the script for me. It counts some prefix, some mixed record stuff, Windows 95 entries. Okay, great. It didn't like so it suggests some of these Windows 95 field offsets might be off a little bit, and I said, well, why don't you just fix that? Like, just fix that for me. So it tries again. And I'm like, yeah, it's not quite right, but let's try this castle parser and a hero record parser. They might have variable widths, but for each map, let's use 46 as the delimiter and print everything, even partial records for the tail of each map. Let's just align them for observation, and then we should be able to point out what records are castle and what records are heroes for both DOS and Windows 95 formats. So this is I'm starting to get it here. I'm making a very, what I think is an intelligent reverse engineering observation and saying, let's just look at these 46s. There's clearly a pattern here. Let's look and figure out what the pattern is and figure out the logic. And then I give it basically what I think is a castle record. I give it a rough spec. Then we've got the player number in byte 3. There's some padding. In bytes 4 and 5, we have the build state low, build state high. And then we have these creature IDs of creatures in the garrison. And then these other bytes are quantities of the creature in the garrison. They're not hero specifications, but they're castle specifications. And I'm not quite sure how to determine the difference between the hero and the castle records. Well, Windows 95 has the same castle record format as DOS, probably. That's my suspicion. But the offsets are slightly off, and they come after the hero records, and that changes the offset. Regardless, let's just align everything by the 46 ending bytes of the record and have a look at it. I want to dump that record for each value on the map. Highlight the values specified in the castle and use the original hero parsing also. Like basically what I had presented up here. This was my hero parsing. This player, creatures, quantities, portrait, artifacts, experience, all of that. So let's just do that and see what comes out. So I ran some of this, got some errors, and basically it wasn't handling the end of the last segment correctly because there was no final 0046. It's basically just zero padding at the end of the file. I can show you that down here. We get this final 46 here, and then the last record has no there's no 46 there. So and then I realized something was off. I was off by 1, so it changed it. Still not correct. Maybe I was wrong in the other way. So basically I fudged and like kind of specifying what the correct count before is to get it to identify my castles correctly. And then it breaks the hero records. So the hero records in Dragon Rider were not correctly parsed at all. I think there's a 4B Sentinel also in the Windows 95 map. So I think the Windows 95 map has both 4B and 4.6 Sentinels. And let's line those up. So the 46 should be parsed as either castles or heroes. And let's just print the 4B Sentinels for now. And then I gave it Castor's 26 bytes from Dragon Rider. So the 17 is a dragon, and he has 1 dragon. And 20 is his portrait, and 23 is the true compass of mobility. So this was how we knew this. And then I give it a specification of which bytes correspond to which. And then I'm still trying to figure out the exact prefix. Like, is it all zeros? What is this? So it takes my information, splits out the 4B records. The castle parsing is now working correctly, but the hero parsing is off by a byte. And what I pasted in there was my named heroes were being detected, but it was, these are the three: Antoine, Astra, etc. But then this is the correct detection that we want. It has the traveler's compass, and then I give it the specific bytes. So I basically gave it a breakdown from a different script, and I'm trying to get it to, like, sort it out exactly. Well, the layout was confirmed. So it basically figures out there's like 5 spawn bytes or something. It still thinks that from an earlier assumption, I now know it's from C7 on the map that means it's going to be like a hero. Actually, C5, C6, C7. Oh no, sorry. It is C7, but it's the auxiliary byte then specifies the index of the hero in this hero listing, the hero records. That index is specified in the auxiliary. That's how the game knows where to place the hero. And so, but before, when I was looking at these hero, spawning these heroes, when I found Castor's data, I thought maybe the first couple bytes were like the location, and they were not. But this is from my outdated speculation from my notes or from my documentation that was just a little bit stale. And so it still thinks they're spawn bytes. So I don't think those are spawn bytes. Let's just treat them as unknown, possibly padding bytes. Can you make that update? And we'll test it. Okay, let's assume my hero spec is off by 1. Decrement the byte spec and remove one of the unknown padding values. Please output all records in the detailed dump, not just the selected records. So it was just selecting stuff that it thought was interesting and sort of matched, like had a possible match. And because it wasn't quite parsing it correctly, it was highlighting junk. It was highlighting like things that weren't quite correct. So garbage in, garbage out. Or if you're reading the format incorrectly, it's all garbage. So anyway, my shift down was incorrect. I actually think that I want to shift it up. So decremented the wrong way. Let's add 2 more and shift this up. And so it looks at Castor's data again and says, oh yeah, if you had added 1 more value there. So somehow it was clipping off 1 when I had the previous data that I had fed it somehow had like clipped this leading 0. And so I was like very, very close. This is Castor and it's correct. Record 5, 6, 7 are heroes too, and they're not quite being decoded correctly. Can you see why? So here I gave it this hero. So this is Castor. Then we have slot 2, Warlock, Castle, probably. This is another hero here with no artifacts. And it's Portrait 11, which I want to say is probably the Sorceress Astra. Or no. Sorceress Astra is 17. This is Antoine the Barbarian. And 08 here is Ambrose. So I know that these are hero records, but they're not quite being identified correctly. So what if 46 decodes a player and 4B decodes an opponent? So I'm just speculating about that. It now detects which, based on my determination of the player tag. So it doesn't cleanly map, so it thinks there's like a parity thing going here, player number parity. So it thinks that 4B is 1 player, like odd, and 4-6 is even player numbers. So it just prevents it from getting unbalanced, or maybe if you have 3 players, like how it would process something like that. So now it is correctly decoding both castles and heroes. And let's write the documentation to specify this. So it made a note about it in my map tail records, updated my map format, but There's some obvious mistakes that I just corrected in the map format now with the creature names. And we had our map loading MD as well. And just giving it some more advice about how to document things. And then I move on to the next one. So now we're moving here to, like, now that I've corrected my reverse engineering of Heroes of Might and Magic 1 format, map format, to process object records, which includes castle records for DOS and Windows 95 formats, and castle and hero records for the Windows 95 format. I have a version of the rebuilt game engine using an outdated decoding scheme, or just didn't decode those values at all. Can you look at the updated specs and code and help me update it? Specifically, I want to load the castle build state from the castle records in the map file. I want the castle build state to be reflected correctly on the castle screen, so it needs to parse the build state. This build state variable might be the wrong size to handle the new format I just reverse engineered, so we might have to update that too and update how it is parsed and stored in memory. So I give it my architecture file, my game state, map loading, map format, and my game, like my main game file resources, which is how certain things are loaded, the castle screen, and I was like, maybe it'll affect rendering. Let's see. So I just threw in render and render map, but I don't think those were necessarily needed. So the map loading logic is in map CPP, so it's not even in resources. Map CPP will call resources to load that information. So the on-disk castle record I had just set to 0xFFFF, all castles. And I ignored the actual data from the record. So now we have to load in build state low, build state high. So we're going to load in these values here, this 9601. This is load state or build state high and build state low. We're going to load these in and translate these into our bitmask layout for the castle here. So we have this. Yep. So this is currently still the FF version. This is the old state of the code before this was all done. So it assumed a bunch of these. And it makes some assumptions. Mage guilds level 2 to 4 come from other sources. We don't know what those are. And then it says, oh, the mage guild level is assigned from spells, not from building state. And like that's just not right. But the AI is like misinterpreting something there. And basically I have some mismatch here, but it says, all right, let's make some changes. Let's add castle buildings from record to map CPP. Then we'll update the initial game state in the castle record. We'll update these values, and then we'll just double check if CS is castle is from the same bit. You know, just double check that. And then it says, watch out, Mage Guild levels 2 to 4 have no representation in the disk build state bytes at all. Yeah, gotcha. So, and this is probably the case. I haven't been able to find a map where you have a Mage Guild level 4. I need to go through some of the fan-made maps, some of the community maps, and see if I can find that. Because I can probably locate the data. And figure out what it is, but I need to make sure that they're also compatible with DOS, because this is the DOS and Windows 95 compatible formats that I'm working on. And then I thought I uploaded the map CPP. I forgot to. So up here, you'll notice I put render map, not map. Oops. So reads those files and does basically the same processing, takes a long time. So we made an update to castle screen. how it assigns the values from the CS buildings state, and then the castle record structure is updated in map.h, and how we parse it and wire it into the initial game state is updated in map CPP. So it's missing the Mage Guild level 4 value. It just forgot that. And it dropped when we only had room for these bits. So basically, it dropped Mage Guild level 4 somehow from the state by putting the castle in there, I think, or the tent. So it just assigned it to a bit, one of the unknown or reserved bits in the low bytes that the map format didn't really use. It just made that Mage Guild level 4. Okay, that's fine. Now the castle isn't loading anything except the default level 1 structure. So that was the bug I was seeing. It was just, I had previously been setting it to all values to show me everything, and it went from everything to nothing. You know, not even a tent or a castle. So nothing was there. Except the default level 1 structure, which, if you remember, is the default behavior of the game. So if the game doesn't have any state data, it will still render that default level 1 structure without the castle or the tent. So it found it was not quite processing it correctly, and we had a couple of back and forth with this, but what I did is I said, hey, you know what? I have this Heroes of Might and Magic 1 record parser script that I did get to work correctly. Why don't you look at that and see what the logic is in that and use that to fix your parsing? And it says, yep, it does pure sentinel scanning. So basically, for some reason, the AI thought that it was a fixed 24 byte castle record that it was looking for. Dumb, but you know, that's how the AI works. It's only as smart as its context, and it makes wrong assumptions regularly. So you have to, I mean, this is what you're going to end up debugging in these situations. So I did that, and okay, the root cause was that it had a bad assumption. Okay, now we fixed that. It's doing what the Python does correctly, and parsing it based on these 46 and 4b values, and then, you know, makes an update to the map CPP. Nope, it's still not correctly copying the data. Okay, well, have another look. And I gave it some of the info, and I said it looks like the aux data from pile byte 9 is being read correctly, but then that lookup in the object sections, castle and hero sections, is not working correctly. Can we look a little closer? Maybe it's being read correctly but not passed correctly. The clue is right here. Castle records is 0 and castle records size is 1. It didn't find any records, but the aux data value is like 14, 7, 9. So these are much higher values than the number of records we're finding. So the records exist in the file. We know, we've seen them. The aux data values are higher, and yet we're not finding them. So there's definitely something with the sentinel scan loop. So it takes another look. I think I gave it some more raw data. So here it had this count, so there's 19 records. It was looking for that. The second problem is these values are the segment index from the full sentinel scan, not an index into castle records only. So the AI was assuming that castle records was 1, and there would be up to some number of those, and hero records was another, and there would be some number of those. And instead, they're just kind of pushed in together. Like the index isn't... They're just crammed in there, and so the index is done by the sentinel, and the ordering is just whatever the game threw in there. So anyway, but my tile 9 for this claw castle is pointing to segment 9 of this scan, not segment 9 of the castle records. So it's a flat list of all segments there, and so I download this latest version. Now it's loading correctly, but the hero generation of a random hero has been stopped somehow. Can you fix that? Why did the hero rendering change? For DOS maps and Windows 95 maps with no hero definition, a random hero should be generated per faction in the entrance of their castle, like before. So it had messed up some skip castle heroes guard if there's a hero record function. So the Windows 95 was expecting heroes, and it would spawn the heroes at the location, and the auxiliary byte 9 would tell you which index to find the hero information to spawn the hero at the location specified by byte 8 in the tile map being C7. That's pretty complicated, but that's how this logic is working. So anyway, the Windows 95 map had come up with this situation where, like in Dragon Rider, Caster spawns outside of his castle. So it doesn't create a hero in the castle in that situation. The other 3 heroes that are the opponents of Caster in that map are also, specified heroes that are not starting in their castle. So that map caused this hero records check, and that had then been kind of implemented for all maps suddenly. And I said, hey, that's not correct. Just for Windows 95 maps, let's only parse non-castle segments as hero records on Windows 95 maps. So it updated how it was checking the Windows 95, and instead of this hero records empty, and then it started spawning correctly. And then let's also read in the garrison info from the castle record. It might be all zeros, but it might not be. Let's read that in and populate the castle garrison up to 5 creature slots from the map file. This may occur in DOS or Windows 95 maps. So it found a bug where basically peasants have the ID of 0, and it was gating based on peasants. Like if the creature ID was 0, it was treating it as nothing, but it was actually the quantity of being 0 is whether or not you display something. So you could have stuff you could have different creature IDs in the garrison of the castle. It wouldn't matter. It wouldn't display them as long as the quantity is 0. So great, this is all working now. So let's update our MD files with the project. And that was the end of that. Well, let me show you the results here. Back to builds. So this was our castle, and we have the correct state loading. We have the well, tavern, this other one. We don't have any garrison creatures, or we didn't have any garrison creatures in the castle here, but I have it open in the hex header, so let's just test that. So let's see, it was 9601, and then I think there was a space, and then I think we can, so let's give her a dragon. How about 17 as dragon, I remember. 1, 2, 3, 4, 5. And then we have the low bit. Let's give her 6 dragons, and let's see what happens in her. I mean, I don't know who will spawn, but let's load it up and see what we have. Oh, that didn't work. So I didn't quite do that right. What is... Okay, well, let's go look at our spec here. What was the actual garrison spec here? I had it. No, it's not there. It's not there. Add it back here. There's the castle. Okay, that is again the castle record bytes. So 0001. And then we had the player number, which is 0. Then we have the building state. And then we have this padding. And then we have a creature ID. So 1, 2. Well. Oh, you know why? I think I did that correctly, but I did it in the wrong map. So let me show you what happens in the real game, because I did this in the map in this game here. See, we have 6 dragons here. So I was hex editing the wrong map. But let's copy this map that I just hex edited. Copy that over to the maps directory in my the one that my build uses. And now let's reload the build. And I bet this will work. Okay. Okay, it didn't. Interesting. Oh, and the reason it didn't work is because I have a separate map directory for this one also. Oh goodness, I have so many map directories because I'm trying to do so many things at once. Okay, now this one should. There we go. Okay, so I gave him 6 dragons, and so that does mean we are editing the map correctly. Now I do have Claw, the correct version of Claw saved here. So I'm going to replace that. I can't replace it right now because it's in use, but it's going to try and open a map file in Visual Studio. Thank you, Microsoft. Okay. I don't know what's going on. I'm not going to worry about permission errors, but I probably need to close the game. So that'll probably work now. Okay, I don't know what's happening with this. Oh, it's probably because it's open in the hex editor. That's why. Sure, change it. There we go. All right, too many files open at once. But anyway, I am very, very happy with the discovery of the castle build state and, you know, the garrison of the castle, just figuring out how to specify this. I now basically have enough information to fully decode the maps of DOS and Windows 95, at least to be able to make the game playable. I still don't know what these last, you know, at the end of any Windows 95 map, there is 20,736 bytes that corresponds to another four bytes of map tile data. And I still don't know what that is. I'm guessing it's Windows map editor, like some kind of optimization to let that load faster, or it's a Windows 95 optimization. Um, I I I really don't know. It could be some kind of additional high quality sound map or something for Windows 95, but I think it seems like it's extra data because I'm able to reconstruct the game from the DOS maps correctly, and that was the goal of. I've been working on that for a little while, and today I really cracked it. This was the breakthrough. So thank you for paying attention through that very long reverse engineering discussion, but that is that is a pretty realistic experience of what you go through when you're reverse engineering. You're dealing with something where you see the pattern, you think it's this, so it's not that. You think it's this, so it's not that, and then you find a pattern and you're chasing down the pattern, and you ultimately end up realizing that somebody just threw the castle records and hero records in together, and they have slightly different lengths and different ways of decoding them, but now we have decoded them.